thank you very much to Jenks for joining us today. And I'm really excited for your workshop on Filecoin basics and storage helpers. So yeah, I'd love to hand over to you to get things started.
Lovely, thank you very much. So hi everyone, my name is Jenks. I am a developer advocate from Filecoin Foundation. I work in the ecosystem working group along with a number of colleagues from Filecoin Foundation and Protocol Labs. My day-to-day job is to come to hackathons, developer conferences to talk about anything related to IPFS and Filecoin and help you to integrate to these technologies fast. So today my talk is going to be a little bit high level about basics of Filecoins. I know that Xiaogang from FEN team has introduced quite extensively what you can do on FEM. I'm going to bring you a little bit back towards a kind of 10,000 feet view of a Filecoin developer tooling and also IPFS related developer tooling, so you can get a good understanding of what those technologies are for, and mix some of these kind of primitives that we offer to be able to come up with something innovative. I'm also going to delve a little bit deeper into storage helpers, which are tools to help you to onboard data, usually smaller data, to Filecoin. And one of the one that we're going to explore is NFT.Storage. It's a very quick way for NFT projects to be able to use IPFS and Filecoin without the hassle of doing a lot of protocol development. Now, so starting from the top, I'm going to do a little bit of intro to Web3 and why. And then how IPFS fits into this grand schema of Web3 movement, and how Filecoin fits into that. Then I'll introduce a few products and tools that you might be able to use in this hackathon. And then we'll talk about what NFT storage is specifically. So overall, one of the most exciting movement that we're witnessing right now is decentralization of the whole entire web. Over time, because of the design choices of web at the beginning, it has encouraged increasingly problematic centralization problems. That includes single point of failures, data monetized by data monoliths, big platforms having control of a lot of data, user data, and they're monetizing. Their business models are based on monetizing these data that users do not necessarily agree. Just about everything we use on the internet right now, the fact that you're watching this live stream from me, most of the stuff that you encounter on your computer system is heavily centralized. They're either controlled by a single entity with their permission, or controlled by single corporations. What we want as a Web3 movement is a gradually decentralized internet, where a few players are doing the same thing instead of one single entity, and eventually to all the participants in the network are helping each other to form a truly distributed web. In this truly distributed web, users can power services to each other. The web is completely censorship resistant, meaning no person can shut you down. It respects people's privacy, but also it encourages people to share information freely. So in this grand movement, what IPFS and Filecoin are doing is IPFS provides the underlying hypermedia transfer protocol like HTTP for the Web3. And Filecoin solves the actual problem of who provides the hardwares for the internet, and who gets to participate and run the infrastructure for Web3. We need completely from the ground up reinvented protocols, but we also need people who can afford resources to be able to contribute to the new internet. Because essentially what we're trying to build is reinvigorate the whole how the internet works. We need both the physical and also the software part. IPFS stands for interplanetary file system, apart from my favorite acronyms in Web3, it is a concept that is really cool, and it is invented with the intention of solving interplanetary communication problems. But it also happened to be a very good peer-to-peer media transfer protocol to be able to facilitate computers to talk to each other in a very peer-to-peer way. Interplanetary file system has a ways and means for computer clusters to talk to each other, and the computer clusters are peers as soon as it is connected to the network, and everyone is the same. There is no leader per se in the network. Everyone has its own unique ID. They talk to each other in an encrypted way. They use services from each other, but also provide services to each other. And they're able to route requests within the network. So think of it as a swarm of computers that plays the same role by itself. So even if you, in this setup, even if you carve out a piece of internet, it's still working fine. It is truly distributed. There is no central server to coordinate the whole network. It is very resilient, and it is designed with offline first principle in it. So there's no way to shut this network down unless you have stopped every single peers in IPFS. And right now, IPFS has about a few thousand nodes running at any point of time. One of the most important technology that IPFS offers is the content addressing plus content routing. Now, the way we look for content on the internet these days is to look for, most of the time, type in a domain and a address behind this domain. Now, domain usually gets interpreted into a IP address, which registers the location of the server on the internet. And there's complicated routing happening in the existing DNS infrastructure to be able to find those servers. And then once you find the servers, the location of the file is interpreted by the server and served by the server. This design from principle is centralized because everyone looks for a location. And if that location is not there, so for example, if the IP address is not available, then you're not able to retrieve the content. So that's why we end up with a lot of 4-false if a server goes down. Now, for content addressing, it works differently. Instead of asking the computer, where is my file? What we are doing is we're asking the computer what file we would like to retrieve. We basically do not care about where the file is. As long as someone has the file, we're going to retrieve it. The network is going to retrieve it and serve it to you. If it happens to be on the same Wi-Fi network as your house, then IPFS is able to retrieve it through the Wi-Fi interfaces. If it is on the other side of the Earth, then it will relay through maybe tens of computers to be able to transfer those files to you. The network, by design, uses content ID to be able to find content instead of a location-based schema. So with that, it is very cool to be able to have a system like this, because if you have this, then you can either keep multiple copies of the files in the network and retrieve it as if it is one, or everyone can just keep a piece of the files and collectively provide the service to one peer that requires those files. The primitives underneath IPFS can also be used for other purposes than transferring files or storing files. IPLD, a data model for Web3, offers hash-linked data structure. You can use it to define any type of data structure that is linked across network and systems. libp2p is a modular stack protocol, much like a network protocol that talks to many network interfaces to allow peer-to-peer networking. It is trusted by many projects such as Polkadot and Ethereum 2.0. So for example, with libp2p, you can build a peer-to-peer chat software that allows a browser to talk to another browser without a intermediary server in the middle. So it's pretty cool. Also, using some of these technologies will make it eligible for their prize pools in this hackathon. So how well is IPFS doing? Since its creation in 2019, there has been quite a bit of adoption in the community. Active contributors went up to 1,000 to 1,000. The 95 percentile to find the file increased to 400 milliseconds. There has been 5 browser integrations that occurred. So 5 different browsers adopted IPFS technology. Vast amount of increase in monthly users. And overall, there has been very, very huge demand on retrieving content from IPFS. The gateway are getting busier. So for your hackathon, if you would like to decentralize your file system in your application, the storage layer, really quick way to do that is to install IPFS on the server that you run, or you can use it locally by spinning up the IPFS daemon in the background process and talk to it via an API. There has been also a number of IPFS clients that's been written to be able to talk to IPFS services really quickly. You can have it hosted on Infura. You can have it hosted on Pinata. So someone else hosts the instance for you, and you just talk to it by IPFS. Or you can host it on your laptop to be able to have a cheaper version of running it. So in effect, you're sort of taking custody of the IPFS node itself. We also have quite a bit of quite a few IPFS gateway to be able to retrieve these content. IPFS.io, for example, is one of those most popular ones. But my personal favorite are Web3 storage, the Cloudflare one, and also the NFT.Storage gateway. So the future of IPFS is very exciting. IPFS wants to build cloud-native implementations of it, and also enable native device integration. So you can run IPFS on iOS or Android. This is the project scope of the IPFS Iron. And it wants to improve the content exchange. Something called a carpool is being built right now. And Unreal Engine and Unity has IPFS plugins that allow game developers to be able to use these technology very easily. IPFS also is trying to get into native tools such as curl, FFPNG, MPG, browsers, and other tools. There's a vast amount of people using IPFS. We don't always know who are using it. So there's a website built for a community to share what they're doing with this technology. Awesome.ipfs.io is a site that is hosted on IPFS and for the community to share how they're using this technology. Ecosystem.ipfs.tech shows some committed companies that uses IPFS. So take a look at them and see if you can use some of the tools to help you in this hackathon. Now, where does Filecoin come in? So IPFS itself does not persist data well. If you're uploading a really unpopular picture or file, it's likely that on the network, you're probably the only node that persists that file. If the file gets deleted from your node, your peers may remember it for maybe fragments of it, might be remembered for another 24 hours, but it will be mostly gone by the end of a day or two. So to encourage people to contribute really expensive hardwares to be able to support applications with millions of users, Filecoin was born. Filecoin is kind of the incentive layer created to provide Web3 infrastructure. As a storage network with lots of hard drives, Filecoin has successfully attracted 3,400 storage providers to join the storage providing activity across 40 nations. And the hardware contribution is not the only contribution they give to the network. On top of the hardware that is committed to Filecoin network for storage providing, they have also pledged a big number of financial commitment to Filecoin. So there are about 160 million Filecoins pledged on the network to secure the network financially. What you're seeing in the middle is a picture of a Singapore storage provider that has about 800 petabytes of capacity. So a server like that, they have 8 racks of it there. So they are one of the very professional storage providers that intends to provide hardware for Filecoin. So Filecoin are trying to attract professional storage providers like them, and there are quite a few of them there. It is a layer 1 blockchain. We're starting from storage, but we don't want to end there. There is active work on data retrieval, so building a decentralized version of CDN network. 2 of them are called Saturn and Titan. There is also FEM, which was discussed in the previous call. This will open Filecoin blockchain to allow developers to innovate on top of it. But what's also very exciting is compute over data. So FEM or EVM or virtual machines for blockchains is not able to compute on really heavy duty stuff. So for example, video processing, you wouldn't do that on chain. And for training AI models, you wouldn't do that via any kind of a virtual machine. But you will need off-chain computing. And Bacalhau and Lilypad, which on top of Bacalhau sort of it provides an incentive layer, is going to provide those primitives for developers to do that. The idea is that if Filecoin attracts the most valuable data there and allows people to retrieve, most of the clients should be incentivized to use our compute layer on top of it, because it is still very expensive to move data around on the internet. The wires are still slow for big data transfer, and processing it on site will be a lot cheaper and more preferred by data clients. For the blockchain nerds out there, you can take a look at this table to find out all of the information about Filecoin chain. So some of the technology that we have used is pretty cool. I would like to point out that Filecoin has the largest zk-SNARK network deployed today. We're actually running a very big zk-SNARK circuit globally on our network. Also, one of the most important crypto primitive that we use is actually decentralized random number generator, DRAND. They're providing verifiable randomness through a league of entropy group of sort of entities that are interested in generating random numbers. And the Filecoin's fairness in its election process, in the consensus, is guaranteed by this crypto primitive. It is pretty cool. So since launch of Filecoin, Filecoin has attracted quite a bit of storage client. In raw terabytes, it has achieved to quite a bit of data. Just in April, from beginning of the year to April 2023, 1 million terabyte was total data has been stored. There are 1,500 unique storage clients. And on some days, we're onboarding more than 1 petabyte per day. There are some famous customers of ours. So UC Berkeley storing their data on Filecoin. So does University of Utah and Internet Archive. If you have used a Wayback Machine, Internet Archive is the organization that keeps crawling the older internet. So you can see the older version of the websites. They are also storing their data on Filecoin, and CERN is storing their experimental data through Atlas experiment, and CO Storage is helping them to store their data. There is quite a few clients like that, But most of the clients are interested in lower costs of storage that Filecoin network has to offer, and also improve data availability. So more points in the world to store their data for resilience and recovery of data. And also working with storage providers that are local, means that you can meet the regulatory requirements easier than using a public cloud, which serves a whole region across a few countries. So those are the main kind of points for Filecoin clients to use Filecoin network. As Xiaogang mentioned earlier in FEM, Filecoin has a complicated storage making process, a storage deal making process. This has been largely simplified by some of the tools that FEM has to offer. But the typical process of a deal making is that a client will have a large amount of data to store, usually more than 100 terabytes or something like that. They will broadcast their deal to the network, and in order to find a suitable storage provider for their data, so finding a home for their data, and then the storage provider will respond to this deal with their pricing, and then the client can select which deals that they want to, which storage provider they would like to go, and storage provider can accept those deals. Now, right after this deal has been consummated, Filecoin data clients will need to prepare the data to be sent to a storage provider. And storage provider, upon receipt of this file, it could be over the wires or physically transferred to them, they will need to produce a proof of replication. So a kind of a first complete proof that they have the data integrity stored on their server. And then from that point on, they will need to provide snippets of the file to prove that they still have the entire file stored on their facility. And towards the end of this storage deal, the client can either renew or let it expire, meaning that the storage provider will no longer receive rewards for storing the files or being slashed for losing the file or going offline. So that's how Filecoin storage deal works. Usually it takes 1 to 2 days to actually store the file on Filecoin, and to retrieve it, client will need to find the storage provider that has their data and offer a retrieval deal, so that the storage provider can also be incentivized to provide the storage back to them. These are through a architecture called actors within Filecoin blockchain. The actors will have different roles. So for example, some actors are in charge of calculating rewards to pay for the storage providers. Some are taking charge of mining operations, and some are for calculating storage powers and facilitating storage market, etc. So these actors are designed for specific purposes in Filecoin chain, and it has been very closed architecture. It's very hard to build a new actor for Filecoin blockchain. After the adoption of Filecoin virtual machine, and the first runtime they have made available is the EVM runtime, this has become drastically more cheap and also quicker for developers to implement new logic. So that's the benefit of a Filecoin virtual machine. You can build kind of data DAOs on top of Filecoin virtual machine. You can build perpetual storage, which is what Lighthouse has done. And you can also build DeFi protocols on top of it. So for example, liquid staking protocols, there has been successfully done on Filecoin. Now, since the launch of Filecoin FE virtual machine, there has been 33,000 unique users on FEM. 5.2 million Filecoins are held by FEM-powered smart contracts. So people are really putting their trust on Filecoin virtual machines to hold their funds and execute properly. There has been 12 successful DeFi projects and locking about 2.9 million Filecoins. This is viewable from DeFi Llama, and 2,700 unique smart contracts deployed in mainnet. So take a look at that. If you're interested in that, you can scan the QR code and go to Starboard Ventures FEM Explorers to find out this information. As a result, Filecoin's ecosystem is growing. We have over 500 startups that is going through what we call a builder's funnel. We have helped projects to be incubated in hackathons by giving out prizes and allowing developers to learn about our technology and utilize them for their new ideas. And then for projects that has a commercial way of going, or a project that needs funding to go a little bit further than just a hackathon gig, we offer developer grants to them. That grant program is still open. And we're helping some promising funders to raise funds from the industry. So we're working with many accelerators in Web3 space, such as Outlier Ventures, to actively provide continuity funding to projects. So we're moving through with a cluster of companies, trying to work towards the greater goal of making Web3 happen. To recap, Filecoin and IPFS is a good match because IPFS provides fast, flexible retrieval through its gateways, local nodes, browsers, however you want to access IPFS network. And Filecoin is great for persistency and verifiability. So on top of, you can think of IPFS as a primitive as well. On top of IPLD, libp2p, you can build IPFS. And on top of IPFS, these technology are used in the Filecoin chain to be able to provide largest distributed storage network. And today, my second topic is about storage helpers, which is on top of IPFS and Filecoin, you can build some tools that are really easy for developers and applications to interact with the network. So it becomes as easy as sending an API call or drag and drop some files to a front-end user experience kind of tools. So there are many tools available. You can go to ecosystem.filecoin.io to find out the complete set of tools. But over here, there is NFT.Storage. If you type in NFT.Storage in your browser right now, you'll be able to go to their site. And it's a very quick sign-up flow with your email or GitHub. And then you will get an NFT.Storage account for you to upload any kind of NFTs for free to store it on IPFS and Filecoin. The idea is that in your NFT smart contract, the metadata should keep a link that is powered by content ID or CID on IPFS. That way that your smart contract that you have transferred to the user or owner of the NFT has a unique file to prove that they own this asset. The asset will never change, because if it changes, the ID will be different because it's a hash digest of the file. And if they happen to lose it, or the developer forgot to pay the server to persist the files, if anyone else on the network upload the same file, it will become available again. So it's really good for highly valuable NFT assets that's being purchased by Web3 customers. There is also a version of NFT.Storage called Web3.Storage. They offer similar features. You can think of it as a developer version of Dropbox, and it's on the SaaS model. So you pay a monthly fee, and it will persist data on IPFS for you, but also backs up its data on Filecoin. What you're seeing on the right-hand side is actually a photo booth that Filecoin Foundation has built for an event called Web Summit. And I did the integration of the software, which is a Flash software, to Web3 storage gateway. So the QR code at the end of this photo booth will allow you to retrieve it from a gateway of Web3 storage. So really anything can be easily integrated because it's just an API call for developers to interact with.
Jenks, I hate to jump in, sorry, but we do have another session starting now. So I don't know if you have any final slides you'd like to share, but yeah, I hate to interrupt. So
cool. Thank you. So I do have a few slides on NFT storage, but most of the concept has been explained. And what I want to mention is this. So NFT tools, NFT.Storage tools is very easy to use. There's web interface that you can drag and drop assets to it, and you can drag and drop many assets to it. And then there are JavaScript SDKs that is able to package the files and send to NFT storage very quickly. And then there's Unreal Engine plugin and like a desktop clients for you to interact with it. So with that, feel free to use this service, and feel free to reach out to me via Slack, Discord, whatever, to ask any questions about Filecoin and NFT storage. Thank you.
Amazing. Thank you so much for all your insights. Unfortunately, we don't have any more time for questions, but everybody do feel free to use the chat here. Jenks, you're welcome to stick around and answer any of those. Otherwise, I have dropped a link for the Discord zone in the channel as well. So any further questions, do feel free to ask those there. But yeah, just on behalf of everybody, thank you so much to Jenks for joining us all today and sharing your insights.
Thanks for having me.